Hello, I am not Mr. Cunningham. Okay, my name is Miss B, if you don't know me, and I am doing the review this unit. Okay, I know the quality is not the best, but you should have received this packet from your Algebra 2 teacher. Okay, you also need your unit circle. Get your unit circle out next to you while you're doing this review. Try all these problems on your own first, leave blank what you don't know, then come back, watch the video. Okay, studying. All right. If you choose to fill out a unit circle on your own, you can earn 1 extra credit point. So if you ask your teacher ahead of time, they will give you a blank unit circle. And if you want to fill that out, you can. You'll earn an extra point on your test. Okay? But we care more about you being able to use the unit circle than memorize it, which is why you will be given one filled in on your test. Okay? So here we are. Use the unit circle to evaluate each of the following, okay? On your unit circle, cosine is your x value, sine is your y value, and tangent is y divided by x, okay? Whoop. Tangent's y divided by x. And the way I remember that, x comes before y in the alphabet, c comes before s. So sine goes with y, cosine goes with x. So cosine of 4 pi over 3, I want you to look for 4 pi over 3 on your unit circle. There it is. Cosine is the x coordinate, so negative 1/2. That's it. The x coordinate at the angle measure 4 pi over 3. Okay, let's do this one. Sine of 7 pi over 3. Okay, find 7 pi. What? There's no 7 pi over 3 on my unit circle. Actually, can we go this way? Nah, I'll keep doing this one. There's no 7 pi over 3 on my unit circle. We are going to need to find a coterminal angle. Your unit circle only goes from 0 to 2 pi. 7 divided by 3 is more than 2. Okay, 7 divided by 3, that's more than 2 pi. So to find coterminal angles, we add or subtract 1 rotation or 2 pi. So 7 pi over 3, I'm going to subtract 2 pi, subtract that extra rotation, okay? 7 pi over 3 is bigger than 2 pi, which means we've gone 1 full rotation plus a little bit, okay? Well, to add and subtract fractions, we need a common denominator, all right? So 7 pi over 3 will stay, but that 2 pi needs a denominator of 3, okay? 2 times 3 is 6. So there we go. 6 divided by 3 is equal to 2. So I haven't changed the value of that number. I've just changed how it looks. Okay? 7 pi over 3 minus 6 pi over 3. 7 minus 6 is 1. So just 1 pi over 3. All right. Is that on my unit circle? Yup. Okay. So now I have found a coterminal angle, an angle that ends at the same place. I'm going to look pi over 3. Sine means look at your y coordinate. So at pi over 3, my y coordinate is root 3 over 2. So my final answer would be square root 3 over 2. Put a box around my final answers. Okay, let's come up here. Sine of negative pi over 2. Okay, maybe you can figure that out by looking at your unit circle. Negative angles mean they go the other way, clockwise instead of counterclockwise, but we can also find a coterminal angle by adding or subtracting 2 pi. So negative pi over 2 plus 2 pi this time, plus 2 pi. Again, we need a common denominator, so negative pi over 2 plus 4 pi over 2. Okay, 4 divided by 2 is 2. So I'm just changing the way that looks so I have a common denominator. Okay, negative 1 pi plus 4 pi, 3 pi over 2. Hey, that's on my unit circle. 3 pi over 2. And they're asking me about sine. So my y value at 3 pi over 2 is negative 1. equals -1. All right, let's come down here. Tangent of pi. Pi is right here. Tangent is y divided by x. So 0 divided by -1. 0 divided by -1. Y divided by x. Okay? Hey, that's 0. That's 0. All right? Tangent of 11 pi over 6. Hey, that's on my unit circle. 11 pi over 6. Tangent is y divided by x. Okay, so let's write that down. There's my coordinates. I'm going to have my y coordinate of -1/2 divided by my x coordinate of √3/2. Fraction in a fraction. Keep, change, flip. Keep the first fraction the same, -1/2. Change this division to multiplication and flip the second one, 2 over √3. Okay, those 2's are going to cancel out. So I just have -1 over √3. All right, we are mathematicians here. We do not leave roots in the denominator. So we need to rationalize this fraction. Rationalize. Rationalize. To rationalize a fraction, I'm going to multiply by √3 over √3. All right? Anything times itself is just that thing squared, right? So what's happening here is now I have -1 times √3 on the top. Okay, that's -√3. And then √3 times itself, that's √3 squared. And then, hey, what do you guys notice? Square root and a square, those cancel each other out. So I'm left with -√3 over 3. Okay, if you could jump straight from here to here, that's fine. But I always think about that. If I multiply a root by itself, the root goes away. Right? Cosine of -pi over 3. That's a negative angle, so we're going to have to find a co-terminal angle. Or it's 12 o'clock. Or you can think about rotating pi over 3 this way. Okay? So -pi over 3 plus 2 pi. Again, we need a common denominator, so -pi over 3 plus 6 pi over 3. Okay, -pi plus 6 pi will give me 5 pi over 3. So this is the angle I am looking at on my unit circle. Okay, 5 pi over 3. Asking me about cosine, so that's your x-coordinate. So 1/2. Okay, equals 1. Be sure to box up your answers. You can see we got a lot of work going on, getting a little messy. Okay. Whoa. So cosine x, sine y, tangent y over x. That's the big key. All right, now we're going to do amplitude, period, and midline. Note if there is a reflection, okay? So let's do amplitude, period, and midline, and also draw a little sketch, okay? So amplitude. Amplitude comes from this number in the front, but it is always positive. Your amplitude is a distance, okay? I would never say I drove -10 miles, okay? Distance. So amplitude is 3. Distance from midline to top. That's our amplitude. Period. To find the period. Period is equal to 2 pi divided by b. Well, what is b? It's me, Miss B. Haha. Okay. This is your b value, the number in front of the variable. It could be x, it could be theta. This is not a 0. If I hear one of you say this is a 0 one more time, I'm going to lose my mind. Okay. Could be 0, or look, could be x, could be theta. Sometimes it's t. Okay. So your period is connected to this number, but it's not equal to it. Okay, period is 2 pi divided by the number in front of x. So 2 pi divided by 4. Sometimes we can simplify that fraction, right? 2/4 is the same as 1/2. So pi over 2. And the equation of the midline, it's a line, so it needs to be y equals. That's where this number comes in here. Y equals -5. Okay, and let's draw a little sketch. Our negative cosine function. Okay, cosine normally starts at the top, but because it's negative, my cosine graph is going to be shaped like that. My students know you got to be drawing sketches and stuff. Okay, let's keep going. Amplitude for this one, 4. Period is a little tricky, huh? I've got x over 3. I like to rewrite these, okay? Let's rewrite this together. I'm going to rewrite this to be, okay, 4 cosine. Instead of x over 3, I'm going to say 1/3 x plus 6. Okay, that makes it a little easier for me to see the number in front of x, which is our b value, right? So 1/3 is our b value, okay? So to find the period, 2 pi divided by b, oops, I guess that's fine. So 2 pi divided by 1/3. Again, remember, fraction and a fraction, keep, change, flip. Keep the top the same, 2 pi. Change to multiplication, flip the bottom one. We're multiplying by the reciprocal. 2 pi times 3 is 6 pi. Equation of the midline, y equals 6. Okay, and if I were to draw a sketch, this one's a positive cosine function. So start at the top, end at the top. I think Mr. Cunningham calls this one the Drake function because you start at the bottom. Now you're here. That was from Mr. Cunningham, not from me. Okay, again, this is a theta. That is what the variable is called. And oh my God, I just told your Drake joke.
I'm back. You guys thought I was gone. The Drake joke?
Yeah,
Good.
for this one.
Started from the bottom. Now we're here. Oh, a negative cosine. Perfect. All right. Bye, everyone.
Let's take an elevator. This might take a while.
Time's flying by.
You thought you wouldn't see him in this video. All right, let's keep going. Again, this is a theta. Theta. It's the same thing as x, right? This is where x was. They've just used a different variable. Okay, so amplitude. Hey, there's an invisible 1 here, right? 1 times sine, so amplitude is 1. Period. Again, 2 pi divided by b, which is just 2. Just 2. 2 divided by 2 is 1. So I'm just left with 1 pi. Equation of the midline, y equals 3. All right, this is a positive sine curve. So it should look like this. Start at the midline, up, down, end at the midline. There's my positive sine curve. All right, amplitude. Again, the number in front, but it's always positive. Amplitude is always positive. I'm going to rewrite this one again because it looks like I have a fraction going on. So I should have -2 sine 1/4 theta. Okay, and hey, there's nothing happening here. So think about what number represents nothing. 0. So I can add a 0 out there. All right, so the period, 2 pi divided by 1/4. 1/4. Keep, change, flip. 2 pi times 4 over 1, which would give me 8 pi. All right, and the equation of the midline, that's the number on the end. If you didn't rewrite this, that's okay. You'd be like, hey, there's nothing on the end. So y equals 0. Bada bing, bada boom. Oh, we didn't draw it. Negative sign. Still starting at the midline, but go down, up. There we go. Look at your beautiful artwork. Oh.
Hey guys,
Wait,
what's happening? Oh wow, this looks good so far.
I know. They were helping me.
Good job, guys. High five.
All right. Next page. This is all our graphing. So basically all the skills we just did here are going to be here. All right, let's zoom in. Sketch 2 cycles of the graph. Okay, that can be either one in the positive, one in the negative direction. You can do 2 in the positive direction. My students, we've been doing 1 positive and 1 negative, but however you are comfortable doing it, as long as you got 2 cycles. They are talking loud out there. Okay. So I'm going to rewrite this so it has, because I see the fraction, so 2 sine 1/6 x minus 3. Again, rewriting it like this, that just helps me out, right? That helps me see the b value a little clearer, okay? So the amplitude is 2, number in front. Period is 2 pi over b. So 2 pi divided by 1/6. See, I'm going kind of fast. That's why I was saying try these out on your own first. Okay, keep change flip. 2 pi times 6 over 1. That'd be 12 pi. And the equation of my midline, equation, y equals -3. Okay, the last thing I need, which they didn't ask me for, but I do need a sketch, okay? Because that is going to help me when I'm actually drawing my graph. So I have a positive sine curve, start at the midline, up, down, end on the midline. Okay, this is what I call the information gathering phase. Okay, now we need to label our axes. That's our next phase. All right. For the y-axis, be sure you label at least 1 and -1 so your teacher knows, hey, I'm counting by ones here, right? You can do 1, 2, 3, 4. Sometimes my handwriting gets messy, so I'm just going to label the 1. Okay. The next thing, I like to make a tick mark every 2 lines. Because what we're going to do is we're going to end up splitting this in half and then in half again. So these 4 lines give me nice markers for my 5 key points, okay? All right, now I need to label. Period, 12 pi. Okay, there's also -12 pi here. Okay, halfway to 12 is 6. So 6 pi, -6 pi. All right, now we've done information gathering. We've labeled our axes. The first thing you need to graph is your midline. Everything on your equation, everything on your graph is based around your midline. Okay, so at -3, so 1, 2, 3. There's the midline. Everything on your graph is based on the midline. Okay, so gathered my information, labeled my axes, I have my midline, I'm ready to go. This is where my sketch comes in. Okay, so I'm going to look for 5 key points. The start, okay, there's 3 different locations that these points can be. It could be at the maximum, could be at the minimum, or it could be on the midline. So this first point, where is it? On the midline, okay, on the midline. I like to do first and last and then kind of cut in half. If you have a different method, if your teacher had a different method, go for it, okay? As long as you get all 5 of your points. So I like to do first point, last point. This one's also on the midline. So all the way after 1 period, after 12 pi, wherever your 12 pi label is, that's where your graph should end. And then I look halfway between the two. Looks like I'm on my midline also. Okay, so halfway between these, should be on this tick mark, I'm on the midline. Right, halfway between my first 2 points, right? I said we're going to cut in half and then cut in half again. So halfway between these first 2 points, I'm at a maximum. Okay, so put your pencil on your midline. This is where these tick marks come in handy. So on my midline, and I need to count up to my maximum. How high up am I going to count? 2. Your amplitude tells you how high the maximum is from your midline. So pencil on the midline, I'm going to count 1, 2. That's that point. All right, halfway between these 2 points, I'm at a minimum. Okay, so halfway between, put your pencil on the midline, count down 2, down 2. Okay, there's 1 cycle, 1 period graphed. To graph this one, you're gonna copy and paste. Okay, so I'm doing the same shape, but now this is the start and this is the end. Okay, halfway between I was on the midline, halfway between those two I was at the max, halfway between these two I'm at the minimum. Okay, be sure you're not reflecting. Okay, you see how this is the same shape twice? Copy and paste it. Okay, you could even do this left one first and then do that one after. All right, next thing. I'm going to go quick through the information gathering. Amplitude is 2, positive 2. Period. Ooh, there's an invisible 1 right there. 2 pi divided by 1, that's just 2 pi. Equation of the midline, y equals -2. And looks like I have a negative cosine graph. Started from the bottom. That is, again, Mr. Cunningham. Okay, there's my information gathering. Now I need to label the axes, okay? Let's do tick marks. Don't forget to label your y-axis, okay? 1 period here, 2 pi, -2 pi. Halfway between would be 1 pi, and -1 pi. All right. Information gathered, axes labeled. Start with your midline at -2. Everything is based around your midline. Okay? So again, my 3 location choices, maximum, midline, or minimum. So where do I start? Starting at the bottom, starting at the minimum. So put your pencil on your midline, count down 2. 1, 2. It's from our amplitude. Okay. Starting at the minimum, I'm also ending at the minimum. I highly suggest you guys do this, by the way. I have to do it every time I graph and I'm a teacher and stuff, so it's doing it to help you out. Okay, starting at the minimum, ending at the minimum. So over here, put your pencil on the midline, count down 2. All right. Halfway between these 2 points is a maximum. Maximum. Okay, so at my halfway mark, I'm going to put my pencil on the midline, count up 2. Okay, then we just got to cut in half again. We need 5 key points. So halfway between these 2 is a midline point. So at this tick mark, I'm on the midline. Halfway between these 2, I'm also on the midline. There we go. Copy paste. Have the same exact shape. And notice I have these tick marks here because you see how I have 1 dot for every tick mark? Getting a spam call. Okay. When you connect this, try and make it curve. Like that. Don't make it like, don't make it too sharp. Okay. Last one. Let's gather information. Amplitude is 4. Period is 2 pi divided by 2. So just pi. Equation of the midline, y equals 1. And I have a positive sine curve, so it looks like that. Okay, we already did a positive sine curve. Maybe I should have changed it. Okay. Putting my tick marks to stay organized. Labeling my y-axis. Period is pi, so I need enough room to fit pi and negative pi. Pi over 2 and negative pi over 2. If you were to graph two periods in the positive direction, this would be pi and this would be 2 pi, okay? So however you want to label these axes, it is up to you. That's why it's part of the points. If you do not label your axes, you do not get full points because that's part of it. You've got to choose what your axis labels are, okay? Gathered my information, labeled my axes. Now I need to draw the midline. So I'm at y equals +1. There we go. Now everything is based around your midline. That's why it goes first. Okay, so on my sketch. Again, only 3 locations you're drawing points. Max, mid, min. So my first point starts at the midline. So first point at the midline. Last point on the midline. Halfway between those two. Also on the midline. Halfway between those two, I'm at a maximum. So I'm going to count up 4. Put your pencil on the midline. Count up 1, 2, 3, 4. Notice this is not at a y value of 4. It is 4 above the midline. That's why it's so essential for you to have your pencil on the midline and count up 4. Okay, same thing over here. Between these 2 points, I'm at a minimum. So put your pencil on the midline, count down 4. 1, 2, 3, 4. Copy paste. 1, 2, 3, 4. 1, 2, 3, 4. Whoops, I missed the dot. Missed the dot. Be sure your 5 points are clearly visible because you are being graded on those 5 points. If you just do curves and wiggles, it's gonna be like, I don't know what's going on. All right. So here is a graph asking about the midline, amplitude, period, and an equation. So for the midline, you are going to take the maximum value plus the minimum value, divide by 2. Amplitude is very similar, but we will be subtracting. Okay, so my maximum value is 2. The minimum value is -4. Okay, so I'm just going to plug those in. So 2 plus a -4 over 2. Okay. 2 plus -4 is -2. Divided by 2 gives me -1. So the equation of the midline is y equals -1. Okay, and we can always sketch that in and see, hey, does that make sense? Yeah, that looks to be about the middle to me. Okay, the amplitude, max minus min. Okay, so 2 minus -4 over 2. That's like 2 plus 4, right? So 6 over 2, 3. My amplitude is 3. All right, the period of the function. The simplest way I've found to find the period is to go from top to top or from bottom to bottom. So what do I mean by that? From here to here. You see this? Bottom to bottom. How far is that? That's from 0 to pi. So the period is pi. That's it. Okay, if you went from top to top, pi over 2, 3 pi over 2, that's also a distance of pi, right? 2 pi over 2 is pi. So then here's the tricky part. Write an equation of a function that has this graph. So first I need to see, is this a sine or a cosine? Is it positive or negative? Okay, this starts at the bottom, goes up and down. So this is going to be a negative cosine function. I also need to find my b value. Okay, remember for all of these, this number here in my equation is connected to the period, but it is not equal to the period. So this pi is not my b value, okay? So I'm going to have to write an equation. The period equals 2 pi divided by b, okay? That's what we've been doing this whole time. So now we're going to use it in a different way. Now I know the period. So I know that pi is equal to 2 pi over b. Okay, I know the period is pi, so I'm replacing period with pi. All right, if you can see this and already guess what b is going to be, then you're golden. You can do that. Otherwise, let's talk through how you would solve this algebraically. So I have dividing by b right now. So to undo division, we multiply. All right. So now I have b times pi equals 2 pi. All right, well, b is not on its own yet. So I'm going to divide by pi. Okay, pi will cancel out on both sides. So then b equals 2. All right, I'm replacing period with the period I see in the function, solving for b. Again, if you just looked at this and you're like, well, 2 divided by 2 would equal 1 pi. That's fine, okay? Either way, we should end up with a b value of 2. And then we need to put everything together in our equation, okay? So I have a negative cosine function, negative. The amplitude is 3, so I should have a negative 3 in front, cosine. My b value is 2, so I should have 2x. And the midline is at negative 1, so minus 1. All right, that is how we build that equation. Amplitude in front, the positive or negative is based on the shape of the graph. This is the b value, not the period. Okay, notice I did not write pi here. And there's my midline. We're reversing our thinking from what we did here, right? Here I gave you the equation, asked you to find all this stuff. Now I'm giving you all the stuff and you have to find the equation. So we're reversing our thinking. Okay? This would be a good time to pause and try this one on your own and then come back and see what I came up with. Okay? Equation of the midline. Max plus min divided by 2. I know my handwriting is not very good. Sorry, you guys. Okay? My maximum value is 2. And my minimum value is negative 2. Okay, so for the midline, I've got 2 plus a negative 2 divided by 2. Well, hey, that's 0. 0 divided by 2, that's 0. So my midline is at y equals 0. And hey, maybe you figured that out just by looking at it. When you do your project, we have a project after this test. Next week, we're going to have a project. You're going to need to show your works. So get familiar with these formulas, okay? Even if you can just see it from the graph. All right, what is the amplitude? 2 minus a negative 2 over 2. This 2 down here is always stays. The only thing that's changing is this midline is plus, amplitude is minus. Okay, so this is 4 over 2, which is just 2. My amplitude is 2, which looks to be about right to me. So it's like that's the amplitude. Okay, what is the period of the function? Okay, again, from top to top or bottom to bottom. I think I want to do these ones because this has got a negative and I don't like working with negatives. Okay, this is a distance from 1 to 5. That's a distance of 4. So the period is 4, not 4 pi. The period is 4. Remember, that is the period, not the b value. I don't know what I'm doing with my hands. That is the period, not the b value. Okay? So the first thing we need to do, period is 2 pi over b. I need to find this b value because that's what's going into my equation, okay? So 4 equals 2 pi over b. Whoops, okay? So let's solve this one together. I'm dividing by b, so to undo dividing, I'm going to multiply. Okay, and I have 4b equals 2 pi. Okay, I'm trying to solve for b. I'm trying to get b by itself. So let's divide by 4. Okay, so now I have b equals 2 pi over 4 is the same as pi over 2. Okay, that is my b value that will go into my equation. Okay, So let's actually put our equation together. Oh, we got to see what shape this is. Okay, so at 0, where do I start? Starting on the midline, but I'm going down. That is our negative sign shape, okay? This is a negative sign function, okay? It's shaped like this. Starting at the midline, going down, up. Okay, so let's put it all together in our equation. Y equals is a negative sine function. The amplitude is 2, so -2 sine. My b value is pi over 2, not the period, the b value. The b value is pi over 2. This should not say 4. Okay, we can say plus 0 at the end, or we can just leave it for the midline.
Wrap it up, homegirl.
I know. Pause to be continued. All right, where were we? It's been half a second for you, but I just went and toured the middle schoolers, the 8th graders. Can you believe you guys were once that little and smelly? All right, let's keep going. So multiple choice. Point P is at the tip of a windmill blade. Okay, so that is our circular object, a windmill. So all these words that we've been using for the graph, amplitude, period, midline, those are all graph words. Now we need to start thinking about circle words, okay? The center is 20 feet off the ground, and the blades are 8 feet long, okay? That's going to be our radius, okay? Radius is a circle word, amplitude is a graph word, okay? Blades are 8 feet long, that is our radius. Point P is currently rotated pi over 6 radians from the point directly right of the center. Whenever they say directly right of the center, that means our 0 degree mark on our unit circle, right? Okay, choose the equation giving the height of point P after the windmill has rotated. Okay, so let's kind of get a standard structure going on here. All right, this is our amplitude, right? Amplitude is a graph word. That is where the radius goes if I'm talking about a circular object, like a windmill, a Ferris wheel, a fan, okay? This is our b value. That's still our b value. That's where we get the period from. K is where we get midline, but there is no midline of a circular object, okay? That is how high the center is off the ground. I ran out of room. Ground. You can't even read that, okay? So, looking at that, our radius is 8, so all of these have a radius of 8. That's good. I'm 20 feet off the ground, so automatically I can eliminate these two, right? These ones show windmills that are 40 feet above the ground, 40 feet above the ground. Okay, but let's check some of the other stuff to make sure. Okay, 20 feet off the ground. This is how we communicate starting at an angle that's not 0, plus pi over 6. That means I've been rotated pi over 6 radians from my starting point. All right. Ooh, big application one, Ferris wheel. Okay, so this was on your third check-in. We're doing it again. There is a Ferris wheel at the local fair. Okay, so we're going to use those circle words, not our graph words. We might not say amplitude or midline. Okay, we're going to say radius and the height, the center is off the ground. Okay, that is the application. So there's a Ferris wheel with a platform for loading passengers directly to right of the center. Okay, let's draw a little picture here. Kind of make sense of our Ferris wheel. Let's pretend like I didn't draw that too long. Okay, there's our Ferris wheel, and they're loading people on right here. Okay, directly to the right of the center. The height above the ground is modeled by this function. Okay, T is time in minutes. That could be helpful after the rider boards the Ferris wheel. Okay, how tall is the Ferris wheel? Let's talk about some of this stuff, okay? I'm actually going to get a piece of scrap paper to talk about it, okay? So let me write down the function. H of t. Okay, let's compare some of our graph words to our circle words, okay? So from the graph, this is the amplitude, right? This is the midline. And this is B. For my circular object, this 10 is the radius. Okay, this is still B. And 40 is the height of the center. Okay, so we see how these numbers mean two different things. Okay, circle. When we're talking about our graph, we say things like amplitude. When we're talking about our Ferris wheel, we say things like radius. Okay, so let's see if we can take that and figure some things out about this picture. Okay, the height of the center off the ground is 40. That means this distance here is 40 feet from the ground to the center. Okay, they're asking me how tall. How do we measure the height of things? Usually from the ground to the top, right? So from the ground to the center is 40 feet. Okay, what other measurement could be helpful here? I need to figure out how high it is from the center to the top. What type of measurement is that? That is the radius. That's the radius, and our radius is 10. Okay? So how tall is the Ferris wheel? 40 plus 10, 50 feet. 50 feet tall. I know it's feet because that's what they said. Okay? Explain your answer. You won't get points if you won't explain. Okay? So 40 is distance from ground to center. 10 is the distance, I'm going to abbreviate, from center to top. I know I just got cut off. Don't talk about it. Okay, that's my full height, the distance from the ground to the center, plus the distance from the center to the top. Okay, how long does it take to complete one full rotation? How long to complete one full rotation? That is literally what a period is. The period is the time it takes to complete one cycle or one rotation. So this is just asking you to find the period. Okay, so how do we find period? Period equals 2 pi over b. Okay, what is my b value? Okay, let's look back at my little sticky note I made. Your b value is everything in front of your variable. We're not using x or theta, we're using t. This is your b value, pi over 20. Not pi, not 20, pi over 20. That whole thing is your b value. So when you go to find the period, 2 pi over b. 2 pi over 20. The number in front of your variable is b. Okay. So now we need to simplify that. Fraction and fraction, keep change flip. Keep your 2 pi, change to multiplication, flip this one. Now we have 20 over pi. Okay. Hey, what just happened? I got pi divided by pi. 2 times 20 is 40. And what are my units? Minutes. How long does it take? 40 minutes. Pretty long Ferris wheel, just to go around once. Okay. Now we need to graph. Pay attention to your answers from here. It will help you with your graph. Okay? my Ferris wheel is 50 feet tall, so I need enough room on my y-axis to fit 50 feet. It's going to take me 40 minutes to complete one revolution, and they want me to sketch two, so I'm going to need enough room for two periods. Okay, so here's how I would label. 40 minutes for one period. So 40, this would be 80. Okay, and you can label the stuff in between, 20 and 60. Enough time for two full rotations, 40 and then 80. Read. Some of you from your check-in, you need to learn how to read. Okay, what's my height? 50 feet. Let me see how many. Always kind of got to plan ahead here, right? So I got 1, 2, 3, 4, 5. Okay, perfect. So I'm just going to label this 10, 20, 30, 40, 50. Okay, if that wasn't enough, maybe I would have had to count by 20s or something. Okay, so now let's sketch that graph. Okay, now let's go back and think about, instead of thinking about our circle words, think about our graph words. So my midline is at 40. So let's sketch that. Midline is at 40. Your x-axis needs to be 0. Your x-axis needs to be 0, okay? Some of you guys were labeling it as like 100. No, your x-axis needs to be 0. So there's my midline. Okay, let's get a sketch. This is a negative sine curve. Okay, so it's going to be shaped like so. And then I'm just going to take all my points, okay? So I'm starting on the midline, ending on the midline. After, be careful, don't go all the way to the end. After one period, I'm also on the midline. You see that? One period is 40 minutes, so I need to squeeze this shape into 40 minutes. Okay? Halfway between those 2 points, also on the midline. Halfway between the first two, we are at a minimum. So put your pencil on the midline. I'm going down 10 for my amplitude. Because I'm already counting by tens, I just have to go down 1 square. Okay, halfway between these 2 points, we are at a maximum. So count, put your pencil on the midline, up 10. Okay, copy, paste, do the same thing. Start and end on the midline. Halfway in between, I'm on the midline. Here I'm at a minimum. Here I'm at a maximum. Connect it all together. There you go, there's your picture. 2 full rotations. Okay, last part. This is like one of the simplest parts, in my opinion. Use your graph to approximate a time when the passenger is 45 feet above the ground. Okay, they just say a time, so you only need to give me 1. Okay, well, here's 40, here's 50. Where's 45? Halfway in between the two. Okay, they say approximate a time. Maybe I should have labeled these axes. This is minutes, and this one is feet. Okay, so approximate a time. Look at all these options. Okay, so I'm going to come down here. About what time is that? This would be 30. This looks maybe like not quite 25, maybe like 23. Okay, you could also estimate from here. This looks somewhere between 35 and 40, so maybe 38. Okay, these are, there's multiple different answers here, right? Depending on how you drew your graph, but try and be as accurate as you can. Okay, I think this one's like 63. This one looks to be about 78. Okay, wherever from your graph. Those are the 4 points I see. Remember, you just need to give 1. You just need 1. But I just gave you 4. All right. Hey, that's it. That's all. Congratulations. Be sure you ask your teacher if you need help. Okay, test is on Friday. Your homework and check-in corrections are due on Friday. Study up. Let's make it a good one. There's a project happening next week, so another test grade. And I think it's pretty fun. So, yeah, I'll see you guys later.